Everyone, today we are going to solve a very important interesting problem, which is majority element. And this video we will not just code, we will understand everything step by step together. So first, let's understand what is the problem is asking, right? What's the problem is asking. So now we have these array nums, right? And now we will calculate. Now we will now what we will do first, we will count total elements. First we need to read this problem, right? Given an array nums of n size returns the majority element. The majority element is the element that appears more than n divided by 2 times in the array. You may assume that the majority element always exists in the array, right? So we will first count total elements. So here is our total elements is 7, right? And now we will calculate n divided by 2. N divided by 2 is 7 divided by 3, 2 is the answer is 3. So basically we are looking for an element that appears more than 3 times, right? More than 3 times. So now let's check together. 5 1 times, 2 times, 3 times, 4 times. So 5 appears 4 times, and 1 2 3 1 appears 3 times. So we can clearly see our answer is 5, right? So now the question is how to how do we solve this? So what we will do is what we will do is first we will sort the array, then we will count elements, and we will track the maximum frequency, right? So here is our problem. And so it's our function, which is majority element. And so now we are starting from our function, right? So now what we will do is we will initialize some variables, like what count. We will use this to count current elements. Like we can initialize a int count, right? Count equals to 0. So we will use this to count current elements, right? And next one is int max count, right? Max count, yeah, max count equals to 0, right? And now this will store the highest count. And next one is what? Majority element. This will store our answer. So int majority element, yeah, equals to what? Nums, sorry, nums of 0, right? First next, okay. Now why are we taking nums of 0? Right? So because we need some default value, and array always has at least one element. And now we will sort the array. So arrays, right? Arrays dot sort nums, right? Arrays dot sort nums. So before sorting, what? 5 5 1 1 1 5 5. After sorting, the all one shifting shift into the front, right? 1 1 1 and 5 5 5, like this, right? So now we can see same elements are together. So now it's become easy for us to count, right? Now we will run a loop, which is for loop for, right? Okay, enter. For int I equals to 0, I the value is nums dot length, right? Yeah, same as previous. uh, so what we will need to do this, -1. Okay, now I plus, right? So now we will run a loop. Now you might be thinking why length -1, right? Now you might be thinking why length -1. So what we are doing is we are comparing current element with next element I plus 1, right? So if we go till last index, it will give error, out of bound index, right? So that's why we stop at length -1, right? Now in this loop, we check are both elements same, right? So if nums of I equal nums of I plus 1, right? Yeah. Now if it is, so if yes, so we increase the count, right? We increase the count, right? And we increase the count. Else, if else else count is 0. Why count is 0? Because if they are not same, we reset the count. Because Now we are starting count for a new element, right? And now here's the important part. If sorry, if the count is greater than max count, right? Yeah, that one. So now here's the important part. Now we check, is current count greater than previous max? If yes, so we update max count and we update our majority element, right? So max count is equal to kiske count ke, right? Yeah. And now majority element equals to nums dot I, right? And we just simply return the majority element, right? Return majority element, right? Majority element, okay. And finally we return our answer, right? So what we did here, we used sorting. Time complexity becomes big of n log n. But this question also asks, we can do it big of n? Yes, we can use Boyer-Moore algorithm, right? So today now first we need to run this. So just click on it, run button, and now we will check. Yeah, it's perfectly working. And we also submit this. We need to submit, yeah, right. So it's perfectly work, right? So you can see. Okay, so today what we did is, first we understood the problem, then we sorted the array, and then we counted element step by step, and we solve it together. If you enjoy this kind of explanation, so like, comments, and subscribe. And in the next video we will solve the using the optimal approach, right? So thank you.